Solving simple equations. So now we get into the actual algebra of this year. We're going to be focusing on solving equations all year, so this is kind of the basis for what we're going to work through for the rest of the year. So let's get started. So equations. First of all, just to clarify, an equation has two expressions, a left and a right, one on each side, and it's got an equal sign in the middle. We know it's an equation because it has an equal sign. If it doesn't have an equal sign, it's not an equation. We can solve equations, and what I mean when I say solve is we're going to try to figure out what value for that variable will make this equation true. So what we're going to do is we're going to use add, subtract, multiply, and divide, our operations that we learned about in chapter 0. We're going to use our distributive property and combining like terms and order of operations to help us get the variable by itself. We know we're done when the variable is by itself and the other side has some expression to represent that variable. So how do we get these variables by itself? Well, we look at the operations that are in the equation and we undo them. We kind of do the opposite. It's kind of like if you put something on the wall by pushing on it, to take it off you have to pull it off. So we're doing the opposite of what got it there in the first place to get rid of it. So our first step is addition. So to undo adding, we subtract. Opposite of addition, subtracting. So m plus 8 equals 15. Notice I've got this line in the middle of my equation right through my equal signs. That just reminds me that I've got a left side and a right side, and that the equal sign is the middle. The equal sign splits an equation into two parts, and what's on the left is equal to what's on the right. So we want to pay attention to the fact that we definitely have two halves and they work separately from each other. Whatever we do to one side, we have to do the same thing to the other side to keep them balanced. It's just like a seesaw. If I have two people on a seesaw and they're equally balanced, if I take one off, they won't be balanced anymore. If I take them both off, they will still be balanced. So I've got m plus 8 equals 15. My variable's over here on the left, it's the m. What's with the m is that plus 8. So I want to get rid of it. I want to get rid of adding. I'm going to do that by subtracting. Now if I subtract on the left, just like my seesaw, I also need to subtract on the right. So whenever I do the left, I have to do to the right also. So if I subtract 8 on the left, I have to subtract it on the right. Now what happens here on the left is that the plus 8 and the minus 8 cancel each other out, and the only thing that remains is m, my variable. On the right, however, I have to do some math. 15 minus 8 gives me 7. So my variable's by itself. This is m, or 1m. There's an invisible 1 that appears all over the place. You can almost always stick a 1 in front of anything. So that's m, or 1m equals 7. So this is telling me that if m here is replaced with a 7, this equation will be true. I'm going to do a check, and this is how we check our numbers to see if they make sense. I take my original equation, I take the variable out, and I put in the number that I think is the solution, and then I do the math and see what happens. So I have 7 plus 8 on the left. 7 plus 8 is 15. 15 equals 15. My solution of 7 is correct. So we can undo addition. We can also undo subtraction. So if I'm subtracting, the opposite of subtracting, addition. So I can subtract to get rid of adding. I can add to get rid of subtraction. So here's another equation. 6 equals 8 minus 10. Notice the variable's on the right-hand side here. Doesn't make any difference which side the variable is on. I still have an equation because I have an equal sign. I still have a left side and a right side, and they are equal to each other. So they're perfectly balanced. I don't want to upset that balance. I want them to be balanced when I'm done doing my algebraic properties, applying them to them. So I see here my a had a subtracting 10 attached to it. I want to get rid of subtracting 10. I do that by adding 10. But again, if I add 10 on the right, I have to add 10 on the left also. So on the left, 6 plus 10 is 16. On the right, not as interesting. Minus 10 and plus 10 gives me nothing. So I'm left with a. The a is the only thing remaining. So I think that a should be 16 to make this equation true. Let's check it. 6 equals 8 minus 10. That's my original. I'm going to take out the a and put a 16 in its place. 6 equals 16 minus 10. Yep, that works. All right, adding, subtracting, multiplying, and dividing. What if I've dealt with those in an equation? To undo multiplying, we are going to divide. Here's my equation. 14 equals negative 2b. Again, notice the middle of my equation where the equal signs are, my left side and my right side. So I have 14 equals negative 2b. here's my variable on the right. I'm going to see what's happening to the variable in order to figure out how to get it all by itself. It's being multiplied by -2. So to get rid of multiplying by -2, I'm going to divide by -2. Notice I'm using a fraction bar for division. I'm not using that line with 2 dots. We've kind of moved away from that in algebra. So I've got a fraction bar on the right, dividing by -2. Fraction bar on the left, dividing by -2. I have -7 on the left, and this leaves me with b on the right-hand side. If I do a mental math check and go back, -2 times -7, yes, that is 14. Now there's a special case as far as getting rid of multiplying. If you are multiplying by a fraction, so to undo multiplying by a fraction, you do that by multiplying by the reciprocal. We talked about the reciprocal when we were working with fraction operations. So let's say I have 2/3 c equals 4/3. So I notice my variable is here on the left. It's being multiplied by 2/3. My first thought would be, it's multiplication, let's divide. But this is dividing by a fraction, and we don't divide with fractions anymore. Highly illegal. So instead I multiply by the reciprocal. So I'm going to multiply by that 3/2, and I'm going to do it on both sides. Now what happens here, here's the magic of what happens, is these 3's cancel each other out, and these 2's cancel each other out, and you're left with 1 in front of that c. So this is really a 1c that remains after we get rid of those fractions. On the right-hand side here, we do our fraction multiplication, and I can simplify out those 3's. I get 4/2, which boils down to 2. So no dividing with fractions still. We avoid that completely. Multiplying and lastly dividing. So I've got x divided by 8 equals 16. Again, notice 2 sides of my equation, the left and the right side. So I'm dividing by 8, which means to get rid of that, I really want to undo it by multiplying by 8. When we're multiplying both sides, we always use these parentheses. So I'm going to put the entire left side in parentheses and put my factor outside. I'm going to put the entire right side in parentheses and put my factor outside of that. Now on the right-hand side, this is pretty straightforward. 16 times 8 is 128. But on the left-hand side, notice I have a fraction, and we can only multiply fractions by fractions. So that means this is really 8/1. And the same thing happens here as happened with our fractions with multiplying. The 8's cancel each other out, and the only things that remain is just the x, which is totally what we want to have happen. So x is equal to 128. If I checked this, I would say 128 divided by 8, yep, that equals 16.